Welcome to qnawire.
So we have this piece of wood being placed on top of water, and the question is asking us how much lead should be placed underneath this wood such that the surface of the wood is such that the top surface of the wood is flush with the surface of the water. So first we should find the volume of the wood, and this is simply going to be the dimensions of the wood. So this will be 0.6 times 0.25 times 0.08. This is going to give us 0.012 meters cubed. So this is the volume of the wood. And as we know, the weight of the wood and the weight of the lead should cancel out with the buoyancy force of the water. And the buoyancy force of the water is calculated by the density of the water times the acceleration to the gravity, and then times the volume that is displaced by the wood and the lead. So if we were to write this into equation, we could say that the velocity of the wood times the density of the wood times the acceleration due to gravity plus the velocity of the lead times the density of the lead times the acceleration due to gravity equals the velocity of the wood and the volume of the wood plus the volume of the lead times the density of water times the acceleration due to gravity. So we can cancel these out and simply FOIL this and say the density of water times the volume of wood plus the density of water times the volume of lead. So in this case, we can solve for the volume of the lead by simply saying the volume of the lead equals. Now we're going to move this term over. So this term goes over to the other side, and this term over here goes to the other side as well. So we have the volume of the wood times the density of the wood minus the density of the water times the volume of the wood divided by the density of the water minus the density of lead. And here we simply need to plug in for our constant. So we have 0.012 times the density of the wood is 700 kilograms per square meter minus 1,000 being the density of the water and 0.012 being the volume of wood divided by the density of water being again 1,000 minus the density of lead. The density of lead is known to be 11,340 kilograms per cubic meter. So we'll just say 1,000 minus 11,340 here. And the volume of this lead is going to be 3.48 times 10 to the negative fourth meters cubed. Now, the mass of the lead can simply be calculated by the volume of the lead times the density of the lead. And this is going to be 3.48 times 10 to the negative fourth times the density of the lead being 11,340. And we now know that the mass of the lead is going to equal 3.948 kilograms. So this would be our final answer for the mass of the lead. And then, of course, this is going to be our final answer for the volume of the lead. So we had to recognize that the volume of the wood and the weight of the wood and the weight of the lead needs to be equal to the buoyancy force of the water. We need to account for both the volumes of the wood and the lead when calculating for the volume displacement of the water, and then you simply solve for the volume of lead, given that we know the density of lead is 11,340 kilograms per meter cubed. And again, your final answer, 3.48 times 10 to the negative fourth meters cubed, and the mass of that lead being 3.948 kilograms. And that's the end of the solution. Thank you for watching.